Okay, so I think even question number 40 here is something similar. So I will not solve the entire question, but I'll just tell you the concept actually. So we have voltages and currents in AC circuits. Okay, these voltages and currents are all not real numbers; they are complex numbers. That means they have magnitude and angle. So the moment we introduce the complex numbers with magnitudes and angles, the question comes is the comparison between the angles of these two. Okay, so whether angle of one is more than the angle of other, that will determine whether one is leading or other is lagging. Okay, so for example, here I can ask a question. In this circuit there is a current I1 going in this branch, there is another current I2 going in this branch. Now whether the I1 is a complex number, I2 is a complex number, between these two whether I1 is leading or I2 is leading, or basically when we are asking which is leading, which is lagging, we are asking the comparison between the angles. Okay, so just for the simplicity purpose and to save time, I will take a small example and tell. So same thing. So let's take I1, I2, two currents. Okay. So I1 current, let us consider it as 7.2 amperes at an angle of 45 degrees. Okay. Similarly, I2 current. So by the way, amperes you can write here or outside also you can write anywhere is fine. So 5.6 amperes at an angle of 60 degrees. Okay. So I got two current values, I1 and I2. So now 45 degrees from where? Okay. So usually we consider some the positive x-axis as the 0 degrees. So with reference to that, I can give a notation, uh, something like this: 7.2 and at an angle of 45 degrees. So this is the current I1. Similarly, if I want to mark current I2, that will be somewhere like this: 5.6 amperes at an angle of 60 degrees. Okay. So you notice the magnitude is smaller for I2 because the 5.6 is less than 7.2, whereas the angle is larger. Okay, so in this case, we say I2 is leading. So now what are the true statements? So the first one is I2 leads I1. Okay. The second one is I1 lags I2. So you can say both ways. Okay. Sorry, you can say it in both ways. So we can also add angle. So by 15 degrees, because the difference between phase difference is 15 degrees. One is 60 and other is 45. Now that I have solved one small example, now I let me go for another one. So this is the our 0 degree line. Okay, and so I will draw two vectors here. So one will be something like this, and the other will be something like this. So for the simplicity purpose, let's take both are 10 amperes, whereas the angle of the first one is minus 30 degrees, whereas the angle of the other one, so let's take, so how much will that be? So this is in the third quadrant, so more than 180. So let's call it 210 degrees. Okay. Let's label them. Let's call this one as IA equal to and IB equal to. Okay, so now tell me, uh, is I1 leading? Sorry, is IA leading? So statement A is IA leads IB. Statement B is IB leads IA. Okay, sorry, AB is getting confused. So let's call this statement X and statement Y. So which one is correct? So is IA leading IB or IB leading IA in this case? So how many of you think the answer is X? What about the answer being Y? IB leading IA? Okay, so there are people who raise hands for both. So there are other people who did not even raise hands for none of the choice, but they are taking time to think about it. But the way to understand here is that uh, you so imagine a person standing here at 0 degrees, right, and looking towards the origin point, and then imagine all the phasors are rotating anti-clockwise. Okay, all the phasors are rotating anti-clockwise. Okay, so that is the standard notation all over the world people are using. Why anti-clockwise? Why not clockwise? It's just a matter of standards. Okay, if I stand at one point and if I look at the diagram and all the phasors are rotating, so in this case, first IA will go and next IB will come. So in this sense, we say IA is leading IB. Okay. So IA leads IB. Okay. What is the angle? So again, 210 plus 30 is 240. So 360 minus 240 you have to do, which will come to 120 degrees, I think. So we can say by 120 degrees. Okay. Okay. Anyway, so just to conclude, so is it possible, like, see, physically it is not in electrical physical quantity it will not happen, but what if I want to multiply IA with IB? How do you multiply these two numbers? So you just multiply the magnitudes, 10 into 10 it will become 100, and add the angles. So 210 minus 30, what is it? 180 degrees. Okay. So so the so if I let me take a red color, we actually get something like this. This is IA into IB. Okay. So so the angle will be 180 and the length will be 100. Anyway, it is meaningless quantity because just for mathematical sense, I thought I will just show you to stop. Okay, so I will stop recording here and yeah.